Hey guys, today I will be giving you a quick review on limits of functions. Let's go. So now, since I, you know, gave you a bit of knowledge about what limits of functions are, let's talk about some discontinuities. Now, before we get to that, let's start with a continuous function. What is it exactly? Continuous functions. It's a function where it's just like this. Now let's imagine a line from here to here. See? It's a smooth line, no drama, doesn't curve, it doesn't really have any holes, doesn't have any discontinuity. And, well, the graph is pretty, smooth, like I said, and the limit equals to the actual value. So, you know, at x equals 8, so we're gonna have something like limit as x approaches 8 of f of x is gonna equal to f of a, and then that's pretty much it. That's that's what that's what's that's what we call a continuous function. Now, now let's talk about removable discontinuity. Now, what is that, you ask? Well, if you see a graph like this, and then same line as before, but instead of an actual point, we have an open circle. Now, what is that open circle? Well, it's a point in the function where it's undefined, so we have an open circle. Well, even though we say that there's no point there, the graph approaches the same y value from the left hand side and from the right hand side. So the value still actually exists. Now, what about jump discontinuity? Jump discontinuity. Now, what is that exactly? Let's say same graph as before, but instead of a straight circle, we have something like this. Boom. Now, if you notice from the two lines, it discontinues here. It suddenly changes elevation. So when you look at the left hand side where they approach this x value point here, you can see that they have different y values. So from the left, let's say this 1, 2, 3, and 4. From the left, it has y equals 4. But from the right, you actually have y equals 2. So since they're different, it's not really something you can get a limit on. So the limit does not exist because they have different y values at this x value right here. Then that's pretty much what jump discontinuities are. And then let's move on. Now, let's move on to infinite limits. Now, what are they exactly? Let's say infinite limits. What are they exactly? Well, something like, okay, same first quadrant. Again, you see a line, something like this. And then this goes all the way up to positive infinity, and this goes all the way to negative infinity. Now, how does that work exactly in limits? Well, we say that the limits is infinite. It's technically, it technically doesn't exist, but we can still specify it if we write something like limit as x approaches a is f of x is equal to infinity. Well, depends on where you're taking it from, the negative or the positive side. Now, you can technically write this or anything similar, and then you'll pretty much have that. So now let's get to some solving. F of x is equal to x plus 2, a, point A is equals to 3, and then sorry about that, L is equals to 5, and ellipsin is equal to 0.02. Now, my professor wanted me to prove that limit of x approaches 3 is, yeah, so we want to prove that. And then, so how am I going to prove this? I'm going to use the ellipsin and delta definition. So now let's say for every ellipsin greater than 0, there is a delta greater than 0 such that if 0 x minus 3 delta, oh sorry about that, then f of x minus 5, oh sorry about that again, oh wait, no, it's not, sorry, I wrote something different, ellipsin. Now remember this, so because we're going to do it step by step. I'll be looking at my notes. I did it in my notes, so pardon me. So if f of x is equal to x plus 2, then f of x, wait, how did I do this? F of x is equal to minus 5 is going to equal to x plus 2, oh no, x plus 2 minus 5, and then that's pretty much going to mean x minus 3. Now let's do this. F of x minus 5 will equal to x minus 3. And then that's pretty much basically the same thing. Now the condition becomes like this. If x minus 3 is lesser than delta, then x minus 3 is lesser than the ellipsin. Now, that is literally always true if we're gonna set something like delta is same as ellipsin. And then that's pretty much it. So yeah, so delta is equal to 0.2, ellipsin is equal to 0.02, and then that pretty much solves this limit right here, or not solve but prove rather. And then yeah, that's pretty much it.